Speaker is Jossé about the Galaxy platform as a groundbreaking fair tool for Earth systems analytical workflows.
Okay. How do I put in?
Yes, this one and then full screen.
Full screen. Okay. Okay. So, hi everyone. So I'm here to present you a bit more about the Galaxy platform and the work we're doing within the FERIS project for the Earth Systems Analytical Workflows. So my name is Jossé, and so first I will present you a bit about what is FERIS, because we heard a bit about it, but we don't have a presentation yet. Then, what is the Earth system, why we're using Galaxy, and the different good practices and tools and workflows that are available in this platform. So, FERIS is a European project of EOSC. The aim is to build an inter-domain digital architecture for distributed and integrated use of environmental data. And here I will present you more the part about virtual environments, because this is where Galaxy fits in. So the Earth system is a complex and dynamic system that encompasses the interaction between atmosphere, oceans, land, and biosphere. For FERIS, we decided about 5 pilots that will represent this Earth system. So we have coastal water dynamics, Earth critical zone, volcano space observatory, ocean biogeochemicals, and marinomics. If you can learn more about these 5 pilots on the FERIS website, or some of the representatives of these pilots are here today, and you can go ask questions to them. So, why Galaxy? So we chose to use Galaxy to represent and analyze these different data, heterogeneous data from the Earth system. Galaxy is a community-driven platform that is already popular in other domains, so for instance bioinformatics, but also in climate and ecology domains. It's totally open source, and it's really based on the FAIR principles. So this is what it looks like. You have on the left side, the blue panel, the different tools that are available on Galaxy. They are divided by sections that represent the different compartments of the Earth system. On the right side, I think it's the other way around for you. But yes, so on the left side for you, you have the history part. So in the history part, you have all the different analytical steps. What? No. Okay, so the green box. The green box is for the history part, so you'll have all the different analytical steps of your analysis. So you can find here the data that you uploaded, the process that you done on your data, the different visualization that you've created. And in the middle panel, this is easy, you can find the different formula where you can input the parameters that you will choose to run your tool. And you can also have in the middle panel the different visualizations. So for instance, if you created a graphics, you can visualize it here. If you have a tabular or a CSV, you can see it in the middle panel. So there is a lot more features here, but this is the quick overview of how it looks like. So a bit more into the best practices of Galaxy. So as I told you, it's a fair tool, and it is based on 3 main principles. The atomization, so the idea is instead of bringing a huge script, so when I'm talking about tools, I'm talking about scripts like Python scripts, R scripts, it's totally language independent. So instead of bringing a huge scripts, you can divide it in elementary bricks, and then you'll be able to change these scripts one by one. Each script needs to be standardized in order to have generalized tools. And once you're happy with your tools, you can then bring them to peer review, where the Galaxy community will make sure that your tool is the best as it can be. So in a bit about the developer side, but I will really go quickly. On the standardization part, you have what we call a wrapper. So this file is an XML file, and it will do the links between your R or Python scripts or any kind of language and between the user. So you can see that we have the formula where the user can input what he wants, longitude, latitudes, for instance. And you can see the same the information that are in the XML files, for instance, the green box and the orange box that you can see. So here you have the standardized things that need to be put, for instance, an ID, a name, a version, the different input outputs, the libraries that your tool is using, and everything. So this is a bit about the user part. So there are many kind of tools in Galaxy, but we can divide them in 3 main branches. You have the batch tools. So these tools doesn't require any informatics skills. You can come in, put your inputs, and just run the tool without having to know anything, and it will bring you the output that you're wishing without to know anything. Then you have the Jupyter Lab tools, where you can launch a Jupyter Lab from Galaxy and have the environment that you need or the set of notebooks that you need. So for instance, there are Jupyter Lab for DivineD, Holovis, Copernicus Data Space, Ecosystem, OpenGeo, and so on. And finally, we have the desktop tools. So from Galaxy, you can launch a desktop tools like you would launch it on your computer, but you don't have to install it. So this is way more easy. And you can have, for instance, QGIS or Ocean Data View. So I told you about atomization, so I'm coming back a bit on that. So for the atomization, the idea is to divide your script in elementary bricks, and then you can create workflows with Galaxy where you can chain any tools one by one. This way, it's easier for the user to understand your analysis. It's also easier to combine tools and create different analyses. So one user can come and see this workflow and say, yeah, okay, that's nice, but I want to use another tool, and you can chain everything like you want. So here, for instance, you can use, I will introduce you this workflow for later on, but this is the coastal water dynamics mock-up workflow of theories. So this is an example of a way more complicated workflow. And finally, one of the Galaxy features is that you have the Galaxy training network where you can find all the tutorials and different guides that will guide you through your Galaxy journey. So from the creation of tools to the creation of workflows, or even on thematic subjects. So the main idea of Galaxy is that if you're a developer, you can create your own tools, or if you are not, you can ask for someone for help to create your tools. Then you can set up your own workflows with the already existing tools in Galaxy. And finally, you can write a tutorial to explain what is your analysis about and how to build it. So our tools in the workflow in ferries. So first, the ocean variable study one. So it's the one that I just showed you. So you can bring your aggregated data set that contains all unrestricted Edmond chemistry data on eutrophication and acidity, and that covers the Mediterranean Sea, into Galaxy. Then you can run the workflow, and from there, the data will go into ODV automatically, where you can go then into ODV, subset your data, and then it will close the ODV, launch DivineD, so the Jupyter Lab with DivineD, create a climatology, and finally, it will launch the last tool, which is again ODV, where you can visualize the phosphate variable. So for instance, when you use this tool, this workflow, you can have the training that goes with it in Galaxy Training Network, and when you launched it and ran it, you can also extract it, for instance, and share it with other people, and extract it in raw crate, for instance. So this is the output that you can find of your workflow. And everything that you've done into your workflow can be seen into the Galaxy interface, and all the steps are in your history. And so here is an example of the image that you can see in the middle panel. Another example is the Argo workflow. So this workflow allows you to retrieve Argo data, biological, chemical ones, or physical ones, variables of the ocean. Once you've retrieved your Argo data, you can then go into PenGeo tools. So PenGeo is an ecosystem of tools to help researchers analyze the data. From these PenGeo tools, you can clean, subset your data, extract the metadata. And once you've done this part, the workflow will automatically launch ODV with your cleaned data. And then you can go into ODV and do your visualization and your different analysis that you want to do into ODV. And so, yeah, you can, that's already said. And then you can directly have the outputs of what you've done into ODV into the Galaxy interface. So the same here, you can see an example of what the tutorials look like. You have some boxes about hands-on and some images that will guide you through the full analysis. So what you need to keep in mind is that Galaxy is an open source platform for fair data analysis that enable users to use tools from various domains, and then you can plug them into workflows. You can also use interactive environments such as RStudio, QGIS, Jupyter Labs, and you can plug them also with other tools and create your own workflows. Everything can be shared and published. You can also create visualization and work with other people. And to ensure the reproducibility, Galaxy capture the necessary information of your analysis to repeat and understand all the data analysis that you've done. So the Galaxy community is really strongly involved into helping the researcher into their analysis and their work. And so there are a lot of collaboration and help that is possible to have. So don't hesitate to reach out, and I'll be happy to help you. Thank you.
So thanks, Marie, for this very nice presentation. Do you have question? Okay.
Look like a very nice tool. I'm going to try it. The only one question I have is, have you anything in performance? Is performance issue that is...
For the performance issue, I'm not sure.
Yeah, performance issue. Is there any performance issue that is...
So Galaxy is, it depends on how you use Galaxy, because you can deploy your own Galaxy on your infrastructure, but you can also use the one that is available on internet. So this one will be based on a cluster that is found in Freiburg. So each user has its own storage place capacity on Galaxy for this part. And there are multiple ways to distribute the calculus to other kind of clusters, that we call that pulsar, which is used to distribute everything so that you don't have everything on the same place and it takes too long. But if you have your own, the Galaxy deployed on your own infrastructure, that is up to you to manage.
Thank you. Thank you for the nice presentation, Marie. I would like to, so I love the workflows, and I wonder if they are machine readable and shareable, so somebody can actually do the reproducibility of what they did.
Yes. For instance, the workflows that I showed you are available. If you go into Galaxy, you can find them because they have tag names. So if you search for Earth system, you can find it, and you can then change anything that you want into the workflows. But you can also, if I do one and I don't put it publicly, I can directly share it by a link with you. And it's also extractable in Workrate. And I didn't use it yet, but I think there are some ways to directly send them to Workflow Hub, for instance.
So they have unique URIs and they result to arrow crates?
Yes.
Okay, that's great. Thank you.